Let's begin year 11s.
Mr. Chan, yeah, can I get this please?
Yes. Okay, so today's aim is to get to inverse functions. But before we do, I just want to make sure that we understand domain and implied domain. Now, in the very first session, you did demonstrate you understand domain. But I want to make sure that you understand the difference between implied domain and your domain. Okay, so let's have a look at this question 2. It's from your textbook. I just chose it out just to select a couple of questions for you to understand what I'm trying to say. So if we have a look at B, and then we're going to look at D, I want you to read the notation for me here, okay? So everything you've been doing up until now, it's all the same. I want you to be able to read that notation. You see, the braces just means this, okay? So when you want to talk about a number, so this number, like this is 0 and only 0, then you use braces and you say this 0. That's why when we say, you know, like this, the notation where we do all real numbers, x is all real numbers except for, and you use the squiggly brackets, the braces, to say this. You're not talking about an interval, you're talking about just 0. So what this is saying is saying, okay, this, whatever's in here, this has, and now this bracket over here, right here, this just means coordinates. And your coordinates have an x coordinate and a y coordinate. For all I know, next time you could do a 3-dimensional coordinate and you have x, y, and z. Okay? But right now we're only dealing with coordinates. It has an x and it has a y. In that x and y coordinate, so this is just telling me you've got x and y coordinates. And this is my function. So they just did semicolon function. So if you read the one at A, it's the same thing. They're just saying this has a bunch of coordinates, and these bunch of coordinates follow this equation. Another way of seeing this is you can just say f of x equals to x squared plus 1. That's the same thing. Okay, they're just using a different notation. So braces means this. You've got coordinates. And the column tells you, okay, what function, what do these coordinates do? What variables do I have? I didn't have to use x and y. I could have used d and t for distance and time. Okay, I could have done that too. Okay, and then give you an equation with d and t in it. So in our case, we're saying we've got variables x, y, and it's only 2 variables, and that's my equation. I've got y equals to x squared plus 1. Okay? So, now that we can read the notation, then what this is really just saying is you've got a function that is x squared plus y squared, which equals to 9. That's my function. Now the question is, what does that look like? What's x squared plus y squared equals 9? What kind of function do I have there? It's a circle. And what's my radius for the circle? Yeah, it's 3. So radius here, we can say r squared, which is 3 squared, which is 9. We can say radius is 3. So we had to just draw the circle. Then okay, let's do with B. Circle, we've got a radius of 3. So 3, 3, negative 3, negative 3. Yeah? So it says, sketch the graph of the following relations. This is a relation. How do you know? Why is it a relation? What test do I do again? Starting from yesterday. What test would I do, Katia? The vertical line test. Why? Because the vertical line test, if it crosses twice, it suggests that you have 2 y values for the 1 x value. So 1x gives you 2 y's. It's not a function, it's a relation. So this is a relation. And now they're saying state its domain and range. Now what I want you to see is when they say state domain and range, we call this an implied domain. Okay, implied because they never told you from the beginning. Now, if you remember yesterday I showed you function notation. See, function notation implies that you're going to have to write a domain, maps onto R, and then f of x equals to whatever it is that you want. This will tell you your domain. Wow, how many birthdays? A lot of people's birthdays. So this is telling you a domain, and it's not implied because they tell you what the domain should be. They might restrict it, they might not restrict it. But when they give you a function and they don't tell you the domain, it's called implied. Okay, so the implied domain, even though they haven't told you for x squared plus y squared equals 9, you should know the implied domain must be from -3 to 3. Okay, so in this case here, I'd say my domain, if we can look at the x values, we can see it's from -3 and all the way up to 3. I've got coordinates around the circle. So therefore my domain is -3 to 3. So domain is from -3 to 3. Okay, notice I'm using an interval notation. If I want to use the range and I wanted to do a different notation, I could say elements of -3 to 3, or I could do -3 to 3. Okay, so I'm teaching you again the same notations. Either way is all fine. Y element means it's a part of, so that's your range is a part of -3 to 3, including. Or you can just say -3 is y is greater than -3 or equal to, and less than or equal to 3. Yeah? Okay, so we've done that. That's our shape, tells me what domain and range. Next question, if I want you to do D, what would be my implied domain? So I haven't told you what the domain is, but square root of 2x. Square root of 2x, what function is that? What does that look like? D. What does D look like? What function is that, Ray? It's a square root function. What does a square root function look like? What does it look like? Yeah, it's like a side-on parabola. So if we were to draw it, this is my side-on parabola. And because it said relation, okay, it's a relation. They said sketch all these relations. So technically, this is my relation. Okay, so this is my relation. If it had said function, okay, sketch my following functions, then you would have went with that. Okay, so it's a relation, and we're like, okay, this is a relation, and we can have positive and negative. We're assuming that square root is plus and minus. But normally, in our methods exams and SACs and whatnot, if they don't put a negative in front of the square root, do not sketch the negative function. Okay, so if this was a normal question that you get in a SAC or a test, I would say sketch like this. Okay, root of 2x should look like that. Okay, and then therefore, if you ask for your implied domains, you see, if you can picture the graph, you can tell me the implied domain, because you can see already the domain is from 0 all the way from 0 to infinity. Okay, and that's called your implied domain. Is that fair call? Right? And the rest, range and domain, is whether you can sketch it or not. Okay? Now, 7 of these ones, let's go back to which one of these is a relational function. And I thought this was nice just because of the notations. Not that you don't know what the graphs look like. It's just I've written it differently. So let's look at A and B. I want you to look at A and B. And if you were to read this to me, what kind of graph do I have for A, logically? What does it mean when it says this, and your coordinates is x4? So what's that 4 telling me? And then you've got x is an element of all real numbers. What kind of graph is this, Satish? It's A? It is a straight line. Now, which kind of straight line? Is it slanted, vertical, horizontal? Which one is it? What is that, Quinn? Horizontal. Why is that? How do you know? Yeah. See, in that coordinate here, they're telling you you've got an x and a y coordinate, and your y coordinate's always 4. Well, if you think about it, if I had to draw a coordinate where y is always 4, this is 4, and x can be any real number, x can be anything, so x can be anything, what you can see is, doesn't matter what x is, x can be anything, but if y is always 4, you get a horizontal line. So if you can visualize it, you can answer the question now. It says, which one of the following is a relation or a function? Is this a function or is it a relation? It's a function. And how do you test it? vertical line test. Now, it is, what kind of function is this? Remember the types of relations you have: a one-to-one, many-to-one, many-to-many, and a one-to-many. What would this be, logically? It's a function, so we know that it has to be something to one. Now, is it a one-to-one or is it a many-to-one? Many-to-one. Because you can see there are many x values for the one y value. So this is a many-to-one function. Whoops. This is a many-to-one function. Many x to the one y. Okay, so I know it's a many-to-one function, and state, domain, and range is pretty straightforward. Range is always just 4, and your domain is obviously all real numbers. Yeah? So domain, x is element of real, range. We know that y is equal to 4, or y is element of 4. Okay, or just the even unit 4 is fine. So the next one, we have b. B implies that it must be. Yeah, so it's a straight line again. This time it's just saying that x is always 2, so you can always have x equals 2. It's a vertical line. Is this a function or a relation? It's a relation. How do you know? You're going to do a vertical line test, but if you do a vertical line test, it crosses infinite amounts. It means that you have infinite y coordinates for the one x value. So if I had to write all these coordinates, you could have at this point 1, 2, 3. You could have 2, 1, 2, 2, 2, 3, 2, 4. And those are the coordinates as you draw the line. And remember I said yesterday, you can put as many x's as you want, but you want one y value to come out of the machine. Right now, if you put in an x, and you get infinite amount of y values, this is not a function. This is called a relation. But what kind of relation is this? I've obviously got many y's, so it's something to many. And this would be it's a one to many. It's just got one x value, which is 2, and it's going to many y values. So I'd say 1 to many. And this is a relation. This is a function. Okay, so I'm just revising from yesterday's lesson what a relation is, what is a function. Yeah? Got our domain range. Now, the implied domain, this is nice to sort of introduce for your next year's work, and this is what you're going to have to use for inverse functions. Okay? What the question is asking you to do is to sketch x squared plus y squared equals 4. This is a circle of radius 2, so I'm just going to quickly draw it. 2, negative 2, 2, negative 2. Yeah? So from this relation, which is true, it's a many to many, it's a relation. You want to form two one-to-one functions, okay, that have a domain from 0 to 2. So how do you write this? So remember, using function notation, you want to describe, you want to change this relation. You want to restrict this only from 0 to 2. So I'm going to restrict this from 0 to 2. Okay, and I only want two one-to-one functions. Now, one-to-one functions means for every x value, you get one y value. Okay, so the question is, how can you restrict this so that you get a one-to-one function? Okay, and this is the tricky part, because what you're trying to say is really this. You want either this one. You see, if you only have from 0 to 2 as your domain, you only want this top half to be one of the solutions. That could be a function, because if you did a vertical line test, it's still a function. If you did a horizontal line test, it's still a one-to-one. Okay, so a horizontal line test will only cross it once. So if I did a horizontal line test right now, you cross it once. If I did a vertical line test, it tells me it's a function. This tells me it's a one-to-one. See, that's why I only want the top half. And this is technically a quarter of a circle or semicircle with a restricted domain. So you remember how to write a semicircle. The first part, B, to write a semicircle, you're just rearranging this equation, and you have y squared equals the root of 4 minus x squared. Whoops, sorry. There you go. And that's, if you want your positive side, in order for it to be a positive graph, that gives you the top half, but you want to restrict your domain so that it's from 0 to 2. See that, if you type that in your calculator, you will sketch this part, and that's called a one-to-one. So the question is, well, what's the other one? Is it 2 one-to-one functions? Well, the other one is the bottom half. You see, if I ask them to give me negative of 4 minus x squared for between x is 0 to 2, this is also another one-to-one. But if I didn't put the plus or minus, what happens is if I include just a semicircle on this side, that is not a function anymore. Okay, this now gives you 2 crosses, and we don't want that. And the key part here, what I want you to take out of it, is to ensure you're getting a one-to-one, because that's the very key step to doing the next exercise, which is 5G, sorry, that's inverse functions. So you can't do inverse functions unless you understand what a one-to-one is. And a one-to-one literally means 1x for 1y, and that means you'll be doing a vertical line test, crosses once. You do a horizontal line test, crosses once, it's a one-to-one function. That's what you're looking for. Okay? And that's the same thing with part 2. You can have a go with part 2. That's from, I think, question 1D, or 10 from exercise 5D, if you wanted to play around that question, restricting the domain. Okay? Now, today's exercise is probably, to me, is the most conceptual one, because even till next year, this is what you're going to be getting tested on. And the only one thing you're getting tested on is literally what I just told you. Inverse functions can only be one-to-one, and I'm going to keep repeating that throughout the inverse functions section. Okay, that's all you have to take out for next year when they're testing you on your multiple choice questions, or if you're doing an exam 1, without calculator, they are only going to test that one concept. Inverse functions are one-to-one. Okay, now what is an inverse function? Here we go. Inverse function is a function in which you are undoing or reversing its operation. Okay, so for example, if you did x squared, the inverse function of x squared is square root. Okay, that's why if you drew the x squared graph, the inverse function looks exactly like a parabola. The only difference is it's on a side. So you now have, this is your x squared and this is your square root. They're inverse functions of one another. That's why they look very similar. Okay. Now, since we know that we need it to be a one-to-one, why is that? Let me show you why. Because when you reverse, okay, what you're actually doing is you're actually reflecting, and I'm going to show you how it works as well. You're actually reflecting along the y equals x line. Okay. Why is that? Because if you think about it, if I gave you y equals to x squared, the inverse function, you're telling me it's a square root function. So what you're actually sketching is y equals to root of x. That's the inverse function. But what you realize is if I asked you to rearrange this now, and if you rearrange that again, this will give you y squared equals to x, which looks very similar to this equation. The only difference is you switched the x and y coordinates. That is why it is a reflection. So whatever coordinates it was over here, let's say if it was 1, 2, it now has switched to 2, 1. That's why we call it an inverse, because you're reflecting along the y equals x, which is what I'm trying to show you here. I'm saying that f of x equals to y, whatever that coordinate is. When x is 1, y is 2. When you do the inverse, which we denote with the -1 on top, that means the inverse. What you're actually doing is you're actually switching the x and y coordinates. And that's exactly what you're doing here. So I gave an example. I said y equals x squared. How do you get root of x? What you're actually doing is you're saying, let's swap. Whoops. You're saying, let's swap the y and the x. And you're going to get now x equals to y squared. So you're swapping them. And you rearrange that. Now, if you rearrange that, you'll get y equals the root of x. And that is called your inverse function. Okay, so if I had, let's say if I gave you y equals to, let's do rid of x minus 2. If I said I want you to find the inverse function of that, okay? The inverse function occurs when there is a reflection of your x and y coordinates. And so what I'm going to do is I'm going to say, all right, to find out the inverse, I'm going to now switch it to be x and y. So all I did was I just switched the x and y's. And now your job is to rearrange this such that you get y by itself. So if you rearrange this now, square both sides, you get x squared equals to y minus 2. Therefore, y must equal to x squared plus 2. This is your inverse function to this. So if you actually sketch y equals root of x minus 2, this is what it looks like. To the right by 2, that's your inverse function. Okay, sorry, that's your square root function, x minus 2. And if I ask you to then sketch x squared plus 2, this is what x squared plus 2 looks like. It's just a parabola shifted up by 2. And you can see that's a mirrored image along this line. See this square root function, or square root relation, sorry, is actually a reflection in that. So this is your, if I just take that away so it doesn't look too messy, we draw it again. This graph, this is your x squared plus 2, and this is your square root of x minus 2. They're inverses of one another, and they would reflect, and then it looks like as if it's being reflected along the y equals x. That's what it is doing. So you've been used to being reflecting on the x-axis. You're very used to reflecting on the y-axis. When you're doing the inverse function, it's actually reflecting on the y equals x line. Okay, and that's harder to see and to sketch, and that's why I'm saying it actually is probably the hardest one for chapter 5 to really get your head around. And we use this notation. So you notice that I switched the x and y's, and it's confusing to write y equals root of x minus 2 and then y equals x squared plus 2. The correct notation for this should actually be f of x equals to root of x minus 2, and then f with the power of negative 1 of x equals to x squared plus 2. This is how we'd show that this is the function and this is the inverse function. Okay. I know that's quite a bit to take in, but the one concept you have to take out was that when you're switching the x and y's and you rearrange it, you will find what the inverse function would be, or the equation for it. And so this then brings up a couple of problems here, because we said a function, when you do a vertical line test, it has to cross once. So the problem with this is with the quadratic. Yes, the quadratic, if I crossed it with an orange line here, if I cross it down, yes, the quadratic is a function. But when you do the inverse and you test this one, this is actually not an inverse function. Okay, it's an inverse relation, but it's not an inverse function, because you can see the square root function or square root relation crosses twice. That's why we have to cut it off and we have to reduce it. Now, when you reduce this, then that means this has to reduce as well. So there's a condition for a graph to have an inverse function. And the condition is, and if I just take off everything so we can start from a clean slate. The condition is inverse functions can only occur if it's a one-to-one. Okay, now logic, why? Because you know how you have one-to-one, and then you have one-to-many, and then you have many-to-one, and you have many-to-many. Out of all of them, the only time you switch the x and y's, which I'm going to do here, if this is your x and that's your y, so 1x to 1y, if we switch them, okay, this will still be, if I switched it to be y and x, this will become 1 to 1. This will become many to 1. This will become 1 to many. And this will become many to many. Right? Whoops. Now I want you to have a look at this. Out of all these four, which ones were functions? Well, these two were functions. Whoops. How do you go back? Ah, that's terrible. Yeah. So, out of all these, oh God. Maybe I'll just circle it. Does this work? Yeah. All right. Out of these four, the only ones that are one-to-one functions, the ones that are functions, is 1 to 1 and many to 1. These are the only two that is a function. So if you start off with a function, the next question is when you find the inverse, you switch the x and y's. When you switch the x and y's, which ones are still a function? This one's still a function, and 1 to 1 is still a function. But this one, when you had many to 1, it becomes a 1 to many. This is not a function. And so that's why the only one that actually works to have an inverse function is that one. That's the only one that if you switch the x and y's, you can still have a function. That's why they said the inverse function can only exist, meaning it would only have if the function itself to begin with was a 1 to 1. Because you can have a function that's many to 1, which is a parabola, a quadratic. That's a many to 1. But as soon as you switch it, it becomes a square root relation. And that's why it's not possible to have a function. That's why I said the most important thing to understand from my last lesson was what is a function. Okay, a function means that your y coordinate is always going to be 1. You're always going to spit out one y value. Yeah? So from here, we understand this is the only concept they're going to teach you. They're really going to try to test you this next year. The only one concept is this one skill, and it will be a whole bunch of inverse functions on your multiple choice section. And that's all they're testing. They're just testing, did you know what a function was? And did you know that inverse functions only occur if you had a 1 to 1 to start off with? That's the only one that you switch, and it's still a function. Okay? So, the example I tried to show over here was just the graph, just to show you that no matter what graph you have, when you do the inverse, it switches. So if it was yx or xy, it just switches and it's a reflection along your y equals x line. And I gave you the logic to x squared and root of x. Now that also means two things as well. So not only are you switching the x and y's, but if you switch the x and y's, you also happen to switch the domain and range as well. So that means the domain of your original function now becomes the range of the inverse. Your range of your original function now becomes the domain of your inverse. And the example I tried to show you was with the quadratic. See, I showed you that if you had a quadratic x squared plus 2, this is x squared plus 2, and I asked you to draw the inverse function, which we knew was root of x minus 2. This is what root of x minus 2 looks like. But that's a relation. But what I want you to see is, you see the range of the quadratic graph was from 2 to infinity. That now becomes the domain of your inverse, which is 2 to infinity, because that is shifting the graph to the left by 2. There you go, left by 2. Okay, so that's what I'm trying to say here, that the range of your domain, okay, becomes the range of the original function becomes the domain of the inverse, and the domain of the original function becomes the range of the inverse. Okay, so those are the properties that you have to take. So if I had to really break down everything that you needed to know for this session, it was this simple idea. Inverse function is a 1 to 1, and those are the two that you had to take out. Okay, so if I could minimize my lesson right now and said the only two things you had to take out of this lesson was just these two. But in order for you to understand this, I had to teach you what a function was. Not only that, I had to tell you what a one-to-one was. Not only that, I have to teach you how to test if it's a one-to-one or it's a function. Okay? And then not only that, I have to teach you what domain and range was, because otherwise this wouldn't make sense. You see, everything was a build-up. And it built up to this one exercise that you'll be tested next year, and it only tests two things. Do you know inverse functions occur one-to-one, and the properties, they switch. That's all it is. Cool? All right? Now I'm going to leave it there. I'm not going to bombard with you too much more information, but that's the two concepts I need you to take out. And so therefore, the exercises for this example, I want you to have a go in the sense that this is your function. This is your domain. I just want you to find for me the very first one, what is the inverse of 2x plus 3? And remember, the inverse occurs when you switch the x and y. So I want you to start off with the first one, which you're just switching this now to become x, and this now becomes 2y plus 3. If you rearrange that, that will tell you what your inverse function is. So I want you to find yourself, what is the inverse function? And that means that I want you to find me what's the domain and range. Because I told you the domain of your original is actually the range of your inverse. So I already know what the range of the inverse is. The range of my inverse function has to be -2 to 1. So it is an element of -2 to 1. I just don't know what the domain of my inverse function is. Now the only way to find out your domain of the inverse is if you find the range of the original. That's your graph. 2x plus 3 is a straight line. You got a domain from -2 to 1. That's your job to find out the range by sketching the graph in your head or figuring it out. Picture it. And once you can find out the range, then you'll know this part. And finding the inverse is pretty straightforward. The inverse would have been x minus 3 over 2. Yeah, so just minus 3 and divide by 2. So my inverse function is pretty easy to find. Range of the inverse is always easy because they normally give it to you in the function notation. That's the only step you have to take. And this, right there, what I just did with you, is a year 12 exercise. How hard was that? Okay, it's not hard. It's just the same thing over and over. And you'll be doing the same thing for this one and that one. Some of them, they'll give you a domain. Some of them, they don't. That's why it's called implied. And you just have to prove the property and find the inverse. That's the only two things you have to do. Okay, but you remember the inverse only occurs one-to-one. Cool? I would leave it at that. Inverse only occurs at one-to-one. I'm going to keep harping on that. Okay, it only occurs at a one-to-one, and that's all you need to know. Okay. All right, I'll stop it there, and then I'll make another lesson another time.